You know that feeling when you apply for something online, maybe a credit card or a loan, or you just upload your resume to a job portal and you hit enter, and literally 2 seconds later, rejected.
Dreaded computer says no.
Exactly. It's so instantaneous. And there's the sinking feeling where you realize a human being didn't even look at this.
Yeah.
I wasn't judged by a person, I was judged by a math equation.
It's a universal experience now. And, the sales pitch we've all been sold is that this is actually a good thing. The logic goes that humans are messy.
Right.
We get tired, we have prejudices, we get hungry before lunch and make bad calls. So if we hand these big decisions over to a machine, we get like pure, cold, objective math, hygiene for decision making.
We think we're scrubbing out the bias. But we've got a stack of research here today that suggests we might be doing the exact opposite. We aren't building a cure for human error.
No.
We're building a high-speed mirror.
And that mirror reflects our own past mistakes back at us. But because it's all wrapped in code, it looks like science, it looks objective.
So welcome to the deep dive. Today, we are unpacking automated decision systems. We're going to explore the difference between calculation and judgment, which turns out to be a massive canyon. And we're going to figure out if we're designing a world that humans actually fit into.
We're also going to talk about a concept called phronesis, which is an ancient Greek term that might just explain why your smart fridge is a genius, but a robo-judge is, well, terrifying.
I love when we get to do philosophy, but let's start with the nuts and bolts, the input problem. In the reading, there was this analogy of the rearview mirror that really clicked for me.
It's the best way to understand how these systems actually learn. We use that word learning for AI, and we imagine, a student in a classroom absorbing truths about the world.
Yeah, but that's not what's happening.
No, it's not.
It's just looking at history, right?
Precisely. The system ingests massive data sets of what has happened to predict what will happen. It is fundamentally looking backward. So the analogy is, imagine trying to drive a car down a winding road, but you are legally required to only look in the rearview mirror.
If the road is perfectly straight, you're fine.
Right. If the future looks exactly like the past, the system works perfectly. But if the road curves, if society changes, or if our values shift, the machine crashes.
Because it doesn't know the road should curve.
It only knows the straight line of history.
And this is where it gets messy, because the past isn't this neutral, perfect thing. The data isn't just numbers floating in a void.
That is the core of the input problem. We tend to treat data like it's a natural resource we dug out of the ground, pure and objective, but data is just codified human behavior.
A fossil record.
It is a fossil record of every decision, good or bad, that we have made.
So let's take hiring. If I'm a tech company and I feed my new AI hiring bot 10 years of my own historical hiring data.
And let's say, purely hypothetically, that for the last 10 years, your managers consciously or unconsciously preferred hiring men for leadership roles. The data shows men got hired, women didn't.
The machine doesn't see sexism or bias?
No. It sees a pattern. It sees male candidate correlates with successful hire. And because its job is to optimize for success based on the data provided, it turns that historical bias into a future rule.
It effectively says, to be accurate to the history, I should downgrade female candidates.
That is wild. It's not trying to be malicious.
No, it's trying to be accurate.
Exactly. It thinks it's doing a good job. It is optimizing for the status quo. It freezes the past in amber and projects it forward forever.
And it gets even darker when you look at things like policing or lending. The notes talked about this idea of proxy data. Because,
Yeah.
I mean, you can't legally tell a computer, don't lend to people of this race. That's illegal.
Right. But the computer is a pattern matching engine. If you tell it to find risk, it will find things that correlate with risk in the historical data. And often it finds proxies like zip codes.
Or something like frequency of police interaction.
That is a classic example. If a specific neighborhood has been heavily policed for decades, there is a massive amount of crime data generated there, even for minor infractions.
Whereas a wealthy, gated community might have the exact same rate of, say, drug use, but no one is getting arrested, so there's no data.
Exactly. So the algorithm looks at the heavily policed neighborhood and sees thousands of data points labeled crime. It looks at the wealthy neighborhood and sees zeros. It concludes, neighborhood A is high risk,
So it sends more police to neighborhood A?
which leads to more arrests, which generates more data, and the system says, see, I told you so, I was right.
It's a self-fulfilling prophecy wrapped in code.
It's a feedback loop.
Yeah.
And the dangerous part is that because it's a computer saying it, we treat the output as objective truth. If a human cop says, I think that neighborhood is bad, we might question their prejudice.
But if a computer says risk score, 98%, we tend to say,
Well, the math doesn't lie.
that's that veneer of mathematical authority. It makes the bias so much harder to challenge because it looks like science.
Okay, so if these mirrors are flawed, and we know they're flawed, why is everyone rushing to automate everything? I mean, why are we letting algorithms decide who gets a loan or how long a prison sentence should be?
Because of the efficiency trap.
Speed. It always comes down to speed.
Speed and scale. Look, if you are a major bank, paying human beings to carefully review 10,000 loan applications takes weeks. It requires salaries, benefits, office space. It's expensive and slow.
And an algorithm can do it in 4 seconds for fractions of a penny.
For the bottom line, that is a no-brainer. You cut costs, you speed up processing, shareholders are happy. But the research we looked at points out a massive hidden cost to that speed. It's about legitimacy.
This is a concept from public administration, right?
It is. Think about the concept of public accountability. Let's say you're dealing with a bureaucrat at the DMV or a loan officer. It might be annoying, they might be grumpy. But if they deny your application, you can look them in the eye and ask, why? You can argue your case. You can say, look, I know my credit score is low, but here's the context. I was in the hospital last year. I'm back at work now. Here are my pay stubs.
A human can understand the story behind the data. They can use discretion. But an algorithm, it's often what we call a black box,
Right.
especially with modern deep learning. The decision-making process is so complex that even the designers sometimes can't explain exactly why the system made a specific correlation.
So you get the computer says no, and if you ask why, the bank just shrugs and says, the model flagged you.
And that is where the social contract starts to erode.
Yeah.
Legitimacy doesn't just come from getting what you want, it comes from the process.
Mm-hmm.
People will actually accept a negative outcome, like losing a court case or being denied a benefit, if they feel the process was fair.
If they feel they were heard.
Exactly. And you can't feel heard by a spreadsheet.
No, you can't. When decisions feel mechanical, they feel arbitrary. It feels like tyranny. You are no longer a citizen with a unique situation. You are just a row in a database that didn't fit the pattern.
And when institutions treat people like data points, people stop trusting the institution.
Which is the perfect bridge to the next section, because we need to talk about what actually makes human judgment different. We've been bashing humans as messy and biased for the last 10 years of tech development.
Yeah.
But the research argues that the messiness is actually a feature, not a bug.
This brings us to a fascinating idea called Moravec's paradox.
Which sounds like a spy thriller, but it's actually about AI development.
It is. Back in the 80s, Hans Moravec and other researchers realized something weird. It is relatively easy to make a computer do the stuff adults find hard, like playing Grandmaster chess, calculating structural lows for a bridge, or diagnosing rare diseases based on statistics.
But it's incredibly hard to teach a computer to do what a one-year-old does.
Exactly. Walking across a messy room without falling over, folding laundry, recognizing that a tone of voice is sarcastic, not literal. The hard stuff is easy for AI, and the easy stuff is almost impossible.
And this brings us to that Greek word we teased, phronesis.
Aristotle's big contribution to the AI debate thousands of years early. Aristotle distinguished between Sophia, which is theoretical wisdom, knowing the rules of the universe, the abstract math, and phronesis.
Which translates to practical wisdom.
Practical wisdom. It's the ability to make the right decision in a specific, changing, messy context where the rules don't quite fit. It's judgment.
The notes highlighted a few elements of this that AI completely lacks. The first one really struck me. Not knowing.
It sounds counterintuitive, doesn't it?
Well,
We buy computers to know things. But a true expert, a human expert, knows when they don't know.
Right.
A human doctor can look at a patient and say, you know, your symptoms fit the protocol for this disease, but something isn't sitting right. I'm going to pause. I'm going to ask a different question.
The AI can't pause. It has to categorize. It's forced to map the input to the existing labels. It doesn't have a category for, this is weird, let me think about it.
It lacks what philosophers call epistemic uncertainty. It is confident, even when it's hallucinating. And then there's the sensory aspect. We usually treat emotion as noise that ruins logic.
But in the concept of phronesis, emotion is data.
It is. I loved the recruiter example here. A resume might check every box. That's the calculation part. But a human recruiter might notice a hesitation when the candidate answers a question about their last job, or a flash of excitement when they talk about a hobby.
That isn't just feelings, that is high bandwidth information processing. We pick up on micro cues, social dynamics, the vibe of a room.
And AI is deaf and blind to all of that. It only sees the text.
And finally, there's lived experience, which seems obvious, but it's profound. I know that if I drop a glass on concrete, it breaks. I don't need to calculate the physics. I know it because I live in a world with gravity and glass.
AI has no being in the world. It has no skin in the game. It doesn't understand consequences. It only understands error rates. And this leads to what the authors call the empathy void.
This is the scary part for healthcare. There was a study cited that showed patients recover faster when they trust their doctors. And trust is built on empathy.
It's a crucial connection. If a machine gives you a cancer diagnosis, it might be 99.9% accurate mathematically, but it cannot help you process that reality. It can say, "I'm sorry," but you know it's a script.
It's a simulation.
And humans are incredibly good at spotting fakes. Genuine empathy requires shared vulnerability. You trust the doctor because you know they are human, they have mortality, they understand pain. The AI is immortal and feels nothing. That absence of connection actually leads to worse medical outcomes because the patient disengages.
So we have a system that mimics the past, can't explain itself, and lacks the basic empathy required to function in society. This creates a legal nightmare, too, the culpability gap.
This is what keeps the lawyers up at night. If we hand over a decision to an AI, say an autonomous vehicle or a medical bot, and it makes a mistake that hurts someone, who is to blame?
Is it the coder who wrote the line? The company that sold it? The user who pushed start?
It creates a diffusion of responsibility. The coder says, the algorithm learned that behavior on its own. I didn't write it. The company says, the user should have been monitoring it. The user says, the machine is smarter than me. I just trusted it.
Everyone points the finger at everyone else.
And the victim is left with no recourse. It allows institutions to shrug and say, the computer did it. It becomes the ultimate liability shield.
Which leads to the rubber stamp problem. We say, oh, don't worry, there's a human in the loop. But is there really?
This is the fallacy of oversight. Imagine you're a safety operator. The AI is right 99% of the time. You sit there all day staring at a screen, click approve. Eventually, your brain turns off.
You suffer from automation bias.
Exactly. You trust the machine more than your own eyes. So when the machine finally does make that one catastrophic error, the human just clicks approve anyway because they've been conditioned to agree.
So the human becomes a rubber stamp. They aren't a safeguard. They are just there to provide legal cover so the company can say, a human reviewed this.
That is a bit bleak. We've painted a picture of biased mirrors, empathy voids, and humans asleep at the wheel. So what's the move here? Do we smash the looms? Do we go back to pen and paper?
No, and the authors are very clear on this. That's not the answer. The world is too complex and the data volume is too high. We need the calculation power.
But we need a totally new type of partnership. We need reward function engineering.
I love this term. It sounds technical, but the concept is actually beautiful.
It is. It's about the division of labor. Machines are optimization engines. They are incredible at finding the most efficient path to a goal. But they are terrible at picking the goal.
It's like the genie in the lamp. You have to be very, very careful what you wish for.
That's the perfect analogy. If you tell the genie, make me the richest man in the world, he might kill all your relatives so you inherit their money. The genie optimized for wealth, but violated your ethics.
So the AI is the genie.
And humans must be the ones holding the lamp. We must become the reward function engineers. We have to define the values, the constraints, the ethics. We have to set the destination.
So we stop trying to make the AI wise, and we let it be smart while we provide the wisdom.
Yes, this is augmented decision-making. Let the AI process the 10,000 documents. Let it flag anomalies. Let it find the hidden patterns in the spreadsheets. It's better at that than we are.
But when a decision affects a human life, liberty, livelihood, health, a human has to step in for the gut check.
We need meaningful human control. Not a rubber stamp, but a mechanism where a human looks at the edge cases, the weird ones, the high-stakes ones, and applies phronesis. They ask, does this make sense in the real world?
We need to value the friction. We've been trying to remove friction to make things faster, but maybe friction is where justice happens.
That's a great way to put it. Efficiency cannot be the only metric. If we optimize our society purely for speed and cost, we optimize away the very things that make us human: mercy, context, understanding.
It feels like we're coming full circle. We started this episode thinking we needed to eliminate human error. But it turns out we can't eliminate the human without losing the only thing that makes the system work.
The world isn't just a math problem to be solved. It's a lived experience to be navigated. Technology is a tool for calculation. Humanity provides the judgment.
So here's the thought I want to leave you with. As we integrate these tools into our jobs and our lives, ask yourself, are we building a world that fits us, or are we trying to shrink ourselves to fit the machine? Are we keeping the tool in our hand, or are we letting it climb into the driver's seat?
That is the defining question of our time.
A massive topic, and I feel like we only scratched the surface, but hopefully that gives you some armor for the next time the computer says no.
Thanks for listening.
And before we go, a quick closing message from Tech9 Labs. We believe that true innovation isn't just about code, it's about conscience. At Tech9 Labs, we are committed to responsible technology operations that prioritize human values alongside digital innovation. Because the future shouldn't just be smart, it should be wise. See you next time.